Again, it's Mr. Rops.
And Mrs. Flynn.
And we're going to look at the derivative of the natural logarithm function. So if we go over and take a look at our calculator, I've taken the liberty to...
I know that graph.
Ah, you do. You're on to me. That is already the natural logarithm of x. And so let's take a look and see what the derivative will look like. So if I graph the derivative now, it looks like that.
Looks like the inverse to me.
It does look like an inverse or reciprocal function. So, yeah, so let's take a look and see if that's true. Let's go over here then and go 1 divide, divide x. And we'll make it bold and see if it actually goes on top of it. And then we'll have a pretty good sense of what's going on.
Oh.
And it does, right on top of it. Now, this part's not part of the derivative over here because x is only defined for positive values of the natural logarithm. So, the derivative of ln x is simply 1 over x.
And if we look in our formula pack, back to this one.
All right.
Let's see.
They say f of x equals ln x.
Where am I looking? Okay. Of course, I always do a little bit. Natural log of x. And f prime of x is just 1 over x. That one's pretty easy to understand.
Okay. So let's actually calculate our derivative. And if I look at this one, this is a chain rule situation. So I got an inside function and an outside function.
So let's first take the derivative of the outside function.
The natural logarithm of x is 1 over x. So 1 over cosine of x.
And now multiply it by the derivative of the inside, which is?
Negative sine.
Oh, I already see something.
Right.
Can I make it better?
You certainly can.
And I know that
Negative sine over cosine.
I get tan in Southern California.
Nice.
Negative tan.
Negative tan of x. Super. Okay, let's try the next one. Here we have a situation where we have product rule.
And
A chain rule in there as well. All right, so product rule, we have u times v prime, and then plus vu prime.
Okay, and we'll call this u, and this is v.
Super.
Okay, let's just start off f prime of x. So u is x squared times v prime.
So,
to find the derivative of this.
Right, so it's 1 over x squared.
It's derivative of the inside times
2x plus v is the natural logarithm of x squared
times 2x.
Right. Now
It's easy to make this one look a lot better.
Yes.
Gone.
2x plus 2x ln x squared.
And just for the sake of factoring.
Right, we could do this.
There we go.
Super. Okay, let's try another one. We have the square root of ln x.
Let's rewrite this. My intuition tells me must rewrite.
Let's rewrite. Get rid of radicals and put them as exponents. All right. So again, chain rule. All right, so we pull the 1/2 down.
The inside function. Subtract 1 from that power.
And we get negative 1/2.
Times it by the derivative of the inside function.
1 over x.
Oh, let's make it look a little better.
All right.
1 over 2x. Bring that right out front.
Right. And we can say square root of ln x on the bottom.
Okay.
Yeah. I don't think it's absolutely necessary to write it in this form. But you should tidy it up a little bit at least. But there we go. All right, one more example.
All right.
Oh my. Wow.
All sorts of stuff going on.
There is all sorts of stuff going on. So if we look at it now, we could do the chain rule, and part of that chain rule would be a quotient rule, and part of that quotient rule would be a power rule.
Wait. This is natural log.
We know things about natural logarithm.
We do. It's really easy to rewrite these using our log properties.
Right. So we know that's natural logarithm. When we divide things, it really means we're going to subtract minus the logarithm of x minus 2, and let's put that to the 1/2 already.
Go into it. Okay.
And so then, let's pull that 1/2 down as well.
That's another thing that we can do, yeah. So now we have natural log of x plus 1 minus 1/2 natural log x minus 2. All right, now to think about the derivative.
Right. Oh, that was a good call to use those properties. It's looking way better now. So I simply take the derivative of natural logarithm, which is 1 over
X plus 1.
times the derivative of the inside, which is just 1.
There we go.
Minus that 1/2, we'll just throw that 1/2 down, I think. The minus 1/2 times in 1 over
X minus 2.
right.
Not gonna trick me this time.
No.
Times 1.
Times 1. All right, so now we just 1 over x plus 1 minus 1 over 2x minus 4. Done.
Okay.
Good enough. All right, let's pause there.